everyone and welcome back to another video where I explain the concepts. In this video, we'll be learning about another transformation of function called the horizontal stretch. If you want to learn about the vertical stretch, check out the other video on vertical stretch and we'll dive into horizontal stretch in this video. So a horizontal stretch of a function f of x is nothing but manipulating our function with a scale factor of 1 by q, which changes our function to y is equal to f of q x, where q's value is greater than 0. So as I mentioned, 1 by q would be the scale factor, and the invariant axis in this function is going to be the y-axis, meaning our y-axis values or the y-coordinates will not change, but the x-coordinates are going to change depending on the value of q. So each point becomes 1 by q times the previous distance from the y-axis. Now, what does this mean? If q is greater than 1, let's look at this graph over here. So here our q value is 2. So if we observe our function in the red line is the new function and the dotted line is the old function. So in the old function, our x value was 6. And now we are saying that f of x is 2 times x value, meaning our x value is now going to become 1 by q times. And since q is 2, 1 by 2 of 6 is going to be 3. Similarly, our value of minus 6 is going to become minus 3. And as you can see, the function or the graph has moved towards the y-axis value. That is because the q value is greater than 1. What if our q value lies between 0 and 1? In this case, the opposite takes place because our scale factor now would become the 1 by q value would be 1 by 1 by 2, which becomes 2 times the value. So in this example, the minus 3 original value of the function of x becomes minus 6. And over here, our function, which initially had the value of 3, would now have an x value of 6. And one thing to observe is our y-coordinates are not at all changing. And this is what the invariant y-axis means over here. So now let's look at some problems. So we have this question, f of x is equal to 5 minus 3x, that is horizontally stretched with a scale factor of 3. So what is the new function going to be? So let's say g of x is going to be now, scale factor is given as 3, meaning that the q value is greater than 1. So this would be 5 minus 3 times of 3x, which is g of x is nothing but f of 3x. So on expansion, we are going to get 5 minus 9x as our new equation, which is the horizontally stretched equation of this function with a scale factor of 3. Now let's look at another question. So in this question, we have 2x squared plus x minus 3 is horizontally dilated with a scale factor of 1 by 2. So again, they've said horizontally dilated and stretching means the same. So we are using a scale factor of 1 by 2. So since this value is a fraction, lies between 0 and 1, meaning our graph is going to be stretched away from the y-axis. So this can be written as g of x, which is equal to f of x by 2. So this is going to be 2 into x by 2 whole square plus x by 2 minus 3. So let's expand the bracket. So we'll get 2 into x squared by 4 plus x by 2 minus 3. If I want to simplify this, I can cancel the 2. So we'll get x squared plus x by 2 minus 3, or I can write it as x squared plus x minus 6 by 2. So this concludes my video about horizontal stretch. If you would like videos on particular topics, please let me know in the comment section.